Hi everyone, in today's lesson we're going to talk about a concept called the mean value theorem. So I'm just going to read from here what the definition says. So suppose f of x is a function that satisfies both of the following. F of x is continuous on the closed interval and f of x is differentiable on the open interval from a to b. So here's a curve from a to b, this red curve. It is both continuous because I don't have to pick up my pencil and differentiable. So what the mean value theorem states is that there will exist a number c such that c is between a and b, and f prime of c means the slope of the tangent line at c will be equal to the slope of this secant line, and that's what this is. So maybe we can write that down in words. It means that the slope of the tangent line at C will equal the slope of the secant line. And the reason why I know that that's the slope is because f of b minus f of a is the slope formula. So it's very similar to Rolle's theorem, except in Rolle's theorem, a and b were two stationary equal points. Here, a and b are not necessarily the same point. So we're going to need to, in order to find the slope of this tangent line, we're going to need to find the slope of this secant line. So let's take a look at example number 1. So again, it says determine the number values of C for which satisfy the conclusions of the mean value theorem. So from -1 to 1. So here's -1, we're here, and then +1, we're here. So from -1 to 1, we want to find the slope. Here's the secant line that connects these two, and we want to find a tangent line to a relative max or min. So here is my relative max or min, like such, right? We want to find that tangent line. Or more specifically, we want to find the C value, maybe in the middle there, that has that tangent line. So if you want to draw it a little bit bigger so you can kind of see what's happening, you've got a point here and a point here. And the curve is kind of doing this between them. Here's the secant line, here's the tangent line. So here's tangent and secant here hitting in two places. So here's your value for A, here's your value for B, and I want to find the C value that's in between both of those that makes this situation true. So in order to do that, we have to use this formula, and here's the formula here. So f prime of C means the slope of the tangent line at C. So since we don't know what C actually is, we can honestly just take the derivative, which is f prime of x, and we can set it equal to the slope of the secant line. And the reason why we can do that is because these are parallel lines here, and if this secant line has a slope, let's just say m of whatever, then this tangent line will also have a slope of that because parallel lines have the same slopes. So the process to find the C value is this. We're going to take the derivative and set it equal to the slope of the secant line. So I'm going to start with f of x here, and I'm going to take my derivative. So f prime of x is 3x squared minus 2x. And I want to set that equal to the slope of the secant line. So in order to find this secant line, I'm going to just show you what I'm talking about here. The secant line is going to be from this value to this value. So you can, since we have a graph, you can count it, or you can actually just do it by hand. So these are your x values. So you can put your original function, your x to the third minus x squared plus 1, you can put it into the y equals, and you can care about just x equals -1 and x equals 1. So go ahead, put the original function into the y equals, and then hit resume when you're ready for the answer. Okay, so for -1, you should have gotten -1, and for 1, you should have gotten 1, as the graph says here. Here's the point 1, 1, here's the point -1, negative 1. So if I want to find the slope, m, it's, if we call this x1, y1, x2, y2, slope is y2 minus y1 over x2 minus x1. So negative 1, 1 minus negative 1 is 2, double negative here. So 2 divided by 2 is 1. So if I want to find the value for c, I need to take my derivative, my f prime of x, and I need to set it equal to the slope of the secant line. So 3x squared minus 2x must equal 1. Now we know to solve quadratics, we have to set it equal to 0. So I'm going to subtract 1 on both sides, and I'm going to do a little guess and test. So 3x and x need to multiply to 3x squared. I need the things that multiply to 1, so 1 and 1. And I need probably a negative 3 and a positive 1. That'll add to a negative 2 after I do my AC. So x is equal to 1, and x is equal to negative 1/3. And all you have to do is check to make sure that they're in the interval. The interval was from negative 1 to 1. So when x is equal to 1, there's going to be a c value, but since that's on the interval, we don't count that one. And negative 1/3 would probably be somewhere here, which goes to that tangent line, which works. So this one we get to keep, and this one we reject because it's on the interval. All right, why don't you take a second and try to see if you can do example number 2. All right, remember the steps that you have to do is take your derivative and set it equal to the slope of the secant line. And that way you will find C. All right, so try it on your own and then hit resume when you're ready for the answer. All right, this is what I got. All right, so if at this point you got stuck, then that's okay. So let me just explain to you what I did. So the first thing was to find the derivative. So here is my f prime. Then the second thing was find my slope. So here's my slope I got was 4. The way I solved it was I put this f of x into the y equals, and I got these points, 2, 14, and then negative 1, 2. So this one's asking, again, for the values of c, but when I took my derivative here and set it equal to my slope, right, then my goal was to set it equal to 0 and factor. But what happened was there wasn't any factors that worked out. I tried guess and test. I did 3x and x, and maybe I put 5 here, 1 here, but nothing seemed, after I tested my outers and my inners, nothing seemed to add to 4. So what this means is, in order to solve for the values of c, they're not going to be whole numbers. So what that means is you would have to use the quadratic formula to solve. And your values for c will be in radical form. Just for purposes of time, we're not actually going to solve it, but I'll just show you why. So if you look from here to here, right, these are the two values. Here's your secant line. This would be the x value that would be parallel, right here. And if you look on your graph, you can tell that it's not exactly on 1 or 2 or even a half. So the only way to solve for those solutions would be the quadratic formula. We'll definitely do an example like that in class, so don't stress. But the main goal was that you were able to find your derivative, find your slope, and set them equal. Okay, so the last thing I'm going to ask you guys to do is this last one, and I'm actually going to have you try this one for homework. This one is very similar to Rolle's theorem. So if you're having trouble answering this, take a look at the video that I did yesterday for Rolle's theorem, and it might help you to determine why the mean value theorem does not necessarily work. And we'll go over this one in class tomorrow. All right, have a good night.